There we go. All right. Good deal. Okay, I will see what we can do here for screen sharing.
And while you do say that, I'm sorry, I hit the record and then I didn't hit the little confirm. So welcome everybody. We're so excited to have Keith Berns, not just greencover.com seeds, but also a regenerative farmer in his own right for many years. So thank you for joining us. Keith, take it away.
All right, can you see my slides okay?
Yes, sir.
Okay, great. Well, this is actually one of the first talks that I did that really kind of got a lot of people interested in what we're doing. So it's called Carbonomics. And I want to, take you through what's going on in the soil. But first of all, I want you to just kind of go through this little thought process with me. Imagine if you came home to your farm later on tonight or tomorrow this weekend, and these guys are standing there. And these men in black say, we are here and we are taking half your ground. We're just taking it. Half your ground, it's ours. You can't farm it anymore. And furthermore, they say, yeah, so half your ground is gone. Furthermore, they say, and all of your equipment and all of your grain bins, all of your cattle, whatever you're using, you can only utilize half of that. So we're cutting your production in half because we're just taking it away. What would you do? I think for most of us, being the good red-blooded Americans that we are, we would not stand for that. We would put up a fight. We would do something extraordinary to keep that from happening. But I'm here to tell you that it's really already happened. Now, it hasn't been the government or an agency or men in sunglasses that has come and taken it away, but we have lost half of our ground. We have lost half of the productive capability that our American soils have had from the beginning. We've lost it to erosion. More than 50% of our topsoil is already gone. And that's the productive engine of the soils that we farm. So it's either gone from water erosion, like this field. This is Hugh Hammond Bennett, who was kind of the founder of the soil health, soil erosion movement. And just look at how dejected he's looking because of that erosion. We've also lost it to wind erosion. It's maybe not as big a deal in Florida, but this is a pretty big deal in Nebraska and Kansas and Oklahoma. And of course, this picture from the Dust Bowl. We know how that happens, but it's not just the Dust Bowl because we see this happen every year. And we see people tragically killed in accidents on the highway because the dust is blowing in so much. This is a picture I took at a rest stop in Iowa, and it's just showing the decline of the average depth of topsoil in Iowa. It went from 14 inches in 1850 to where in the year 2000 it's only 5.5 inches. And I'm guessing if they put up another pillar in 2025, it's not going to be more than 5.5 inches. And Iowa has some of the greatest soils in the world. And I know that, they're in Florida. You guys are much more challenged. You don't have the deep topsoils that a lot of us are privileged to have out here in the Midwest. And so it's even that much more important that you protect the soil that you do have. And it's not just the fact that we've lost so much soil to erosion, even the soil that we still have, we have lost more than half of the organic matter that's in that remaining soil, and it's led to far less productivity. This is a picture, I believe this is from Dave Brandt's farm in Ohio. So Dave's farm is soil is on the right. This is what it should look like. Deep, dark, black soil, 4 or 5% organic matter. The soil on the left is not from another state, it's from right across the fence line, from a conventional farming neighbor who has farmed the carbon out of his soil, and that's what it looks like. So the same soil, different practices, completely different results. So here at Green Cover, and I'll just give you a little bit of background here. Green Cover, what gets us up in the morning every day is that we are here to help people regenerate, steward, and share God's creation for future generations. That's what we do, and that's what we've got 55 employees now. When we first started, we had none, and it's really grown. But each one of them is fully committed to this. We do also farm here in Nebraska, as Lauren had mentioned, and so this picture that you're looking at is an aerial shot of essentially right where I'm sitting. But this used to be farm ground, and in 2011, the company was growing fast enough we had to start building. And so we farm here in south central Nebraska. We farm a couple thousand acres, corn, beans, cereals, cover crop seed, integrating some livestock, not as much as we'd like. So all of these things that I'm going to talk about, we have struggled with these things. We're doing these things. We're trying these things on our own farm, as well as helping other people do it as well. And so I show you this picture to just show you how kind of how fast green cover has grown, but also the soil health movement, the cover crop industry. And it's been really fun and really exciting. And one of the cool things that we get to do as being a company that was kind of there in the beginning, as the soil health movement has started, is we have people reach out to us and say, hey, we want you to be part of this project or that project. And so a number of years ago, the Soil Health Institute reached out. They said, we're making this documentary about soil health. It's called The Living Soil. If you haven't seen this film, I would encourage you to watch it. You can just go to livingsoilfilm.com. It's free to watch. You can go to YouTube and look it up. I think it's been viewed 5 or 6 million times. But they said, we want to make this documentary about soil health. And one of the things that we want to demonstrate, of course, the principle of soil health, of always having a living root in the ground at all the time. So they wanted a picture. This is our picture here of the combine running in the field, picking corn, planting cover crops at the same time. We said, yeah, sure, come on out. We'd love to be part of that. So I just want to show you a little clip of this. So they sent this really professional film crew out, and they had this big drone. It's like, oh, this is going to be really cool. So the hired man goes and hooks up the big John Deere tractor to the air seeder, and I jump in this thing and I take off, and I'm going down the road, and I'm just thinking, wow, this is going to be cool. We're going to be famous. It's going to be in a movie, and just as you think, man, things can't get much better than this. God has a way of kind of humbling us when we get a little too big for our britches, because you see things like this happen then, and you know, this type of thing happens to all farmers. We all do stupid stuff like this, but most people don't have this captured on high definition drone footage like we do. And it's, if God's grace was with us, because that was the absolute best place this could have happened, a fairly level place. We didn't suffer significant damage. But I show that to show that we are real farmers, and we do dumb things too. So anyway, this talk that I put together is a way to help people understand one of the most complex systems in God's creation, and that's the soil and the soil ecosystem. And I do it by comparing it to another complicated system, but it's one that we understand so much better because we live and breathe and work in it every day. And that's the economy of a country. And so Carbonomics is comparing what's going on in the economy of a country to what's going on in the soil. And so there's these different economic principles, supply and demand and currency and capital and all these things. And we understand intuitively how those work within an economy of our country. But I'm going to show you how these also work in the soil. And it just puts things in a little bit different perspective, and it will help you understand how all the different pieces of the puzzle fit together. So the first thing that we need to understand is when it comes to the economy of the soil, it's all based on solar energy. It's all based on sunlight. And really, as farmers, what we're trying to do is, we sell corn or soybeans or cattle or wheat or whatever, but really we're capturing sunlight and we're turning it into something of value. And then within this economy that's powered by the sun, there's three main players. There's the plants, there's the soil, and then there's the animals. And for the purpose of this talk, cattle, sheep, the livestock is very important, but really what I'm going to be talking about is the tiny little microscopic animals, the biology, the bacteria, the fungi, because they play such a critical role in making this economy work the way that God created and designed it to work. And so I'm going to show you how these things all work together within the confines of an economy. So the first economic principle is supply. You can't have an economy. You can't have a system that works without having something to sell. You have to produce something, you have to make something in order to sell it. You got to generate income somewhere. So from plants, what are they doing that way? They're producing carbon. That's the job of a plant. Photosynthesis, you're all familiar with this, but it's CO2 plus H2O, so carbon dioxide and water. With the energy of the sun and the chlorophyll cells in a plant, they're creating this compound called glucose, C6H12O6, and that becomes the building block of everything else that's going to happen. Now, oxygen is a byproduct, but this glucose molecule is the basis, really, it's the basis of all of our life because it's what is the building block of all the food that we eat and everything that goes into the ecosystem is really based on this. So plants are producing carbon through photosynthesis. Now, it's not going to stay as glucose. We're going to see how it gets turned into lots of other things as it goes through the plant, as it goes through the system. But that's what plants are doing. They're taking CO2, which is a waste product. People call it a contaminant. It's really not. It's the building block of this whole system. But plants are taking that and water and making this very, very valuable molecule as we'll see it go through the system. The soil is supplying nutrients through the minerals. If you look at this chart, these are the minerals that plants need to grow. Now, nitrogen is not coming from the soil, it's coming from the atmosphere, as we'll see. But these other things, potassium and phosphorus and calcium and magnesium and on down the list, many of these things are what our soils are made up of. Now, some soils are deficient in some of these, but most of our soils have pretty good supply of a lot of these. They're just not available to the plant, as we'll see as we go through. So the soil is providing minerals. It provides a habitat for roots and biology. It gives them that ecosystem or habit for them to live. And then also, very importantly, it provides water storage. So as we look at the water cycle, it's providing that. That's what it's doing on the supply side of this economic framework. And then the biology, it's producing nutrients through fixation, through cycling, through availability. We'll look at how that process works. And it's also providing a lot of really cool defense and protection mechanisms. And so, as we look at these systems, the biology is what often gets ignored in our modern farming systems, but it's the piece that really drives all this home, as we'll look at as we go through here. So, supply is great, but it does you no good if you don't have demand. So, an economy has to have both. It has to have supply and demand. And so, within this economy of the soil, the demand side, plants need those nutrients and need that water from the soil. So that's the direct need that those plants have. They also need to be serviced by being protected and supported. If you think about a plant, it can't move. It can't move, so it has to depend on partners to keep it alive, to keep it healthy, to keep it growing. So it has to get those services. It has to get everything that it needs without ever moving. And so plants they're really smart communicators. The system is designed for them to not rely just on themselves, but to rely on this economy that's going on in the soil. The soil has to have carbon. The soil cannot function without carbon. I showed you that picture earlier from Ohio, the good soil on the right, the bad soil on the left. The difference is how much carbon is in there. And when you have a high carbon soil, it can do great things with very little inputs. When you have a very low carbon soil, it's going to need some additional inputs. It's going to need a lot of biology. And, frankly, there in Florida, you guys have a lot of sandy soils that don't have a lot of carbon, but that doesn't mean they can't get better. I've never seen a soil that's been so bad that it can't get better. In fact, the worse that it is, the easier it is to improve it. And so you shouldn't be trying to compare yourself to somebody in Ohio or Illinois that started out with great soils. What you need to compare yourself to is what you started with and what that soil would have been before it started getting farmed and what could it get back to. And so it's going to be different benchmarks, but the soil needs carbon and there's great ways to get carbon into the soil to make it better. It also needs service. The soil has to be protected. If you leave bare soil out there, it's going to wash away, it's going to blow away, as we saw those pictures earlier. And it doesn't matter how much improvement you do to your soil, if it erodes away, you've lost it all. And so it's very important that we protect it. And then the biology, this has very simple needs. It needs food, it needs a place to live, it needs oxygen to breathe. And if you give it those things, you essentially give it, food and shelter. They will do great things for you. And so it's a very simple system, but you need to be able to feed these things in order to make it work. Now, just like in a strong human economy, one of the best indicators that the economy is strong is low unemployment, because low unemployment means the vast majority of everybody is involved in the economy. And they're not just involved in the supply side or the demand side, they're involved in both. They have to be making a contribution on both sides of that equation. And that's what we see in a strong soil economy as well. We need everybody involved. We need everybody producing. And so it's strongest when the animals and the soils and the plants are all producing and consuming. And diversity, I cannot stress how important diversity is when it comes to this, because as we have seen throughout history, when an economy is based just on one thing, the Irish potato famine maybe is one of the best examples, but we see examples of this all the time. When a company is only making one thing, when your little local economy is all dependent on one thing, you're so dependent and you're so precarious. Great example, Lexington, Nebraska. It's a town about 100 miles from here. Their whole economy was based on a Tyson meatpacking plant. People show up right after Thanksgiving, and they're basically said, "Don't come back to work tomorrow. We're closing the plant." 3,000 jobs gone overnight in a town of 10,000 people. Well, that's going to wreck that economy because they did not have much diversity. And so we need to have diversity in our human economies. We need diversity in our soil economies. Now, as we're talking about the economic principles here, I think we have to acknowledge the fact that we are giving our system a lot of welfare. So when we externally provide the plant with everything that it needs from the outside, primarily through fertility inputs, crop protection inputs, when we do that, we weaken the economy because we are artificially supplying things that should be coming from within the economy. And that's plain and simple, that's what welfare is. Now, I like what Abraham Lincoln had to say about this, because there's a time and a place where we need to help people, and there's a time and a place where you need to help your soil. You just absolutely have to. The problem becomes when we continue to do that long after either the people or the soil should be able to do those for themselves. So Abraham Lincoln says, you cannot help men permanently by doing for them what they could and should do for themselves. And that's often what we get into in our agricultural systems is we get ourselves into a state of dependency on the external inputs, and we can never break free of those because we're not allowing the system to work the way that it was created to work. And that's largely because we've ignored the biological component. And we got to get that back involved if we're ever going to break out of this state of welfare where we're having to put so many inputs into our system. We have to do that through the biology, the way that it was created to work. So we got supply and we've got demand, and the third economic principle is currency. And currency is incredibly important because it allows goods and services to be exchanged much more efficiently. Back before there was currency and you had to trade beads or you had to trade animals, or, the barter system can work really well. It's just not very efficient. You can't do quick and efficient and fair transactions. It's just very, very difficult, and it makes an economy very slow, very cumbersome. So currency allows you to, you can get online, you can buy anything you want and just pay for it because you've got currency. And that makes an economy really go fast. And in this economy of our plants, we have the perfect currency, and that's carbon. Just think of carbon as the cash. Think of carbon as the currency that drives the whole system. And let me show you how it works here. So a plant through photosynthesis is making that glucose molecule. It's making that carbon that I showed you. It doesn't stay in the plant though, not all of it. Only as much as 30 to 40, sometimes even as much as 50% of the carbon that plant produces does not stay in the plant. It's leaked out through the root system. And I've got a really cool picture later on here that'll show you of that. But it's leaked out through the root system as a payment. Think of it as a cash deposit, a cash payment. And it's being paid to all of these biological organisms. They're being hired, if you will, put on payroll. But that only is going to work. The plant's only going to continue to pay them or give them that free liquid carbon if they're getting something in return. Plants are actually pretty smart. If they're not getting a return on that investment that they're making through those root exudates, they'll stop putting as much root exudates out. And so if you're in a soil that has no biology in it, you'll have very few root exudates that are going out because that plant knows there's nothing there to give them a return on their investment. So the good soils will have lots of root exudates, the poor soils have very few, and that makes the good soils better and the poor soils worse. So, and that keeps you locked into that system of welfare because the biology isn't there to provide all these services. Now I have to provide that through a jug or through a sprayer. And so carbon makes this all work because that biology isn't going to do these jobs if it's not getting fed, if it's not getting paid, and carbon is the perfect currency to make this work. Carbon is really interesting. It's essential to all life forms. We're 19% carbon by weight. It can form over 10 million different compounds, and it starts as glucose in the plant, but it gets turned into thousands and thousands of different carbon compounds just within that plant, and then into even more different carbon compounds within the rhizosphere and the soil system. It's incredibly versatile in forming all these different compounds. It's the most important but the most overlooked of all the plant nutrients. We never talk about carbon when we talk about the nutrients that our plants need, but it's so incredibly important, and it's the main food source for all this biology that I've been talking about. When we have carbon in our soil, it normalizes our pH. So if you're too high or you're too low, that matters less when you have higher carbon soils. It increases your cation exchange capacity, again, in your sandy soils. Carbon will fix in a lot of those problems that you're having. It will make all those problems less acute. It increases the availability of these important nutrients, and it can help reduce the availability of things that can build up to toxic levels like sodium and aluminum. Think about it as a currency. It can be collected through photosynthesis. We looked at that. It can be spent like any currency as it's traded to the soil organisms. You can save it, as we'll see here with soil organic matter that we're going to look at next. And it's important. It's desired by all members of the economy. I know a lot of people talk about Bitcoin and other types of cryptocurrency, but until that's desired and accepted by all the members of the economy, it's really going to struggle to be a legitimate, true currency across the economy. Now, that may happen someday, but until it's desired by all members of the economy, it's not going to work. It also has different states. Carbon can be gas, as in the CO2 in the atmosphere. It can be liquid as it moves up and down through the plants. And it can be solid carbon, which, is fixed in our bodies and in the bodies of the biology in the soil. And it can move from one form to another, just like you can take cash, you can write a check, you can use a credit card. Carbon can go from gas to liquid to solid in just a very short period of time. It's incredibly diverse. It's the perfect currency that drives this system. And the more you have, the better it is. So, you probably all have heard from your parents, and if you're a parent, you probably have said this, the phrase, money doesn't grow on trees, right? But in our system, it literally does. It grows on corn plants and soybean plants and wheat plants and trees and everything else because we can literally print our own money when we have plants out there photosynthesizing and pumping carbon into the soil, which is kind of exciting. As a farmer, we can increase that cash flow of that carbon. And when we do that, when we have excess currency, you can now turn that into capital. And that's what happens as you save money, as you're earning more than you spend. You can start now to accumulate that. You can save that. You can turn that into other kinds of assets. So, capital is simply stored or saved currency that you turn into assets that you need for growth and stability. And in our soils, that is our soil organic matter. And we could talk for a week just about the benefits of soil organic matter, but I think we all understand how important that is. That's that long-term stable carbon in the soil. It's not fluctuating in and out like the carbon cycle when a plant is growing, but it's a long-term capital storage. And when we look at capital-rich economies, and frankly, the United States is probably the most capital rich economy the world has ever seen. And that's why we have had such a strong economy over generations and over centuries, because when you have access to capital, you're productive, you're stable, you're resilient, and you're efficient. Green cover could not have grown as fast as we did if we didn't have access to capital. Now, we didn't have that in our bank account, but we were able to go borrow money at a very reasonable rate. And so we had access to capital, which allowed us to be productive and resilient and efficient. And it's the same way in our soils. When your soils have high organic matter, and when I say high, higher than what it was, So if you're starting out at one and you get to two, you're going to see a big difference. And if you're at two and you go to three, you're going to see a difference. And those soils are always going to be the most productive, the most stable, the most resilient, and the most efficient at producing. They're going to have they're going to be the last ones to show signs of a drought, last ones to get the disease. They're going to be the most productive. And it's that carbon, that long-term stable soil organic matted carbon that's really driving that. Now, here's the thing though, just like you can't build your savings account unless you're earning more money than what you're spending. I mean, that's just a fiscal principle that applies to everybody except governments because they apparently are immune to some of those rules. But as an individual, we can't increase our savings. We can't invest in things unless we're bringing in more than what we're sending out. It's the same way in the soil. You will never build your soil organic matter if you're putting more carbon out of your system than what you're bringing in. And over the years of farming in such a way that we were losing more carbon than what we were putting into the soil, our organic matter levels have gone down. And that's why that one picture with a really light colored soil, that had been farmed in a conventional way, lots of tillage, lots of monoculture, very little biology. The carbon kept getting less and less and less. And the other system, a regenerative system with diversity, with cover crops, with biology, he put more and more and more in. So that was his savings account. And you just simply can't do that. And so that's why cover crops are such an important part of any type of soil health or regenerative agriculture system, because cover crops are putting carbon into the soil through those root exudates. And again, I've got some pictures to show you of that, but it's putting carbon into the soil and we're not harvesting it. We're not hauling away bushels of corn. We're not hauling away bales of hay, pounds of beef. Cover crops are putting carbon in without taking carbon out. And that's why they're such an incredibly powerful tool if you're going to build your organic matter levels. Now, the next set of economic principles is going to be energy and resources. And so you can't build an economy without energy. Our economy is largely based on energy, and the cheaper our energy is, the more our economy grows. The cheaper prices are, the happier everybody's at. So energy drives the system. And we're very fortunate in the agricultural economy in that our energy is coming from the sun. The sun is powering photosynthesis. We don't have to plug in a plant in order for it to do its job. It just needs to soak up the sun. And we're very fortunate that our plants are solar collectors, but they're much cheaper and easier to install than man-made solar panels. So in this big building right above me here, I've got solar panels right above my head across this whole building. We're generating close to 100 kilowatts, but it was expensive. It was a $200,000 project to do that, where I can go out and plant plants for, $20, $30 an acre, and I can capture vast amounts of sunlight very cheaply, very efficiently. It's just a great way to capture that energy. And they're essentially doing the same thing. They're taking the solar photons and they're turning it into a usable form of energy. And we can say that a healthy soil economy should not need significant purchased energy inputs. And we can say that because we know that these deep soils that we have here in the Midwest, and there's places in Florida that would have, some really good soils, those were built over centuries, over generations with no additional energy input. It was just the energy of the sun, the minerals in the soil, the livestock, the bison and whatever other animals would have been wandering around. These soils were built with no additional energy input. Now, once we start farming in a manner where we're exporting crops, yeah, we're going to have to put some energy back into the soil. But I'm going to show you why the number one energy cost on almost all farms, it's not diesel fuel, it's not propane, it's not electricity, it's not natural gas, it's not any of those. The number one energy cost on our farms is going to be nitrogen fertilizer. And let me show you why that is. As we move from energy over into resources, the number one resource that plants need to grow is going to be carbon, but it's pulling that out of the atmosphere. That CO2 is providing the majority of that carbon source for that plant. We don't have to pay for that. CO2 is free. And in fact, some people may be getting paid to take it out of the atmosphere, which good for you if you're doing that. but we're not paying for carbon, even though it's the number one thing that plants need. Now, number two is nitrogen. And nitrogen is when you look at this pie chart of the atmosphere, the carbon dioxide, I don't know how well you can see it, that little pink slice of the pie at the very top, that's how much CO2 is in our atmosphere. It's about 4/100ths of 1%. Now, it's not 4%, it's not 4/10 of a percent, it's 4/100ths of 1% of the atmosphere CO2. Very, very small fraction, but yet our plants are so efficient, they can pull the carbon that they need out of that tiny fraction. And we don't pay anything for that. Now, nitrogen is the blue part of this pie chart. 78% of our atmosphere is nitrogen, and it's huge. It's a huge amount, but yet as an industry, we're spending $5 billion a year buying nitrogen fertilizer for our plants. We spend zero on carbon. We're spending 5 billion on nitrogen. Well, here's the reason why. And there's good news and there's bad news. So that nitrogen in the atmosphere is held as dinitrogen. It's two nitrogen molecules, and they're bonded to each other with three sets of very strong covalent bonds, which renders it inert. And the good news is it doesn't kill us, because if you've ever had a whiff of anhydrous or a whiff of ammonia, you know what that can do. I mean, it would literally melt you from the inside out. So there would be no life as we know it on Earth if our atmospheric nitrogen was not held as dinitrogen. So that's the good news. The bad news is just like you breathe it in and you breathe it right back out, it's 100% inert, does nothing to your body. Plants are the same way. Plants will take in vast amounts of nitrogen in through the stomata as they're bringing in the atmosphere to strip out that CO2, but they can do nothing with it. They cannot break that bond, that dinitrogen bond, and so they have to essentially exhale that nitrogen right back out, and they can do absolutely nothing with it. So, in order for plants to get nitrogen, that bond has to be broken, and it has to be recombined then with hydrogen and oxygen to make these forms of nitrogen that a plant can actually use. And we can build these big factories to do this, but it's a very energy intensive process. And so when you're writing that check for nitrogen fertilizer, you're not writing the check for nitrogen, because of that 78% of the atmosphere above every acre of crop ground in Florida and Georgia and Nebraska and everywhere across the world, every acre you have 30,000 tons of nitrogen in the atmosphere right above every acre. So there's not a nitrogen shortage, there's a shortage of usable forms of nitrogen. So what you're paying for when you're buying nitrogen is the energy that it takes to break that bond and put that nitrogen into a form that you can use and then get it shipped to your location. That's where the money is going. It really should be on the energy side of things, not on the nitrogen side. But here's the good news. What takes us $5 billion to do? God has given us these tiny little bacteria that do the same thing. So this is rhizobia bacteria that have colonized the soybean plant. So legumes, and don't ever tell people that legumes can make their own nitrogen, because they can't. Legumes have no more ability to take atmospheric nitrogen than a corn plant does. However, legumes have figured out how to form these relationships. They form these partnerships, this economy with rhizobia bacteria. The rhizobia bacteria can produce the right enzymes to break that nitrogen bond and combine it with hydrogen and oxygen. And right there in that root nodule, they're making nitrogen into a form that plants can use. Super cool. And it makes us be able to grow soybeans with no added nitrogen, which is great. But as cool as this is, that's a superpower to break that nitrogen bond. Rhizobia bacteria, they can't eat that nitrogen. That's not a food source for them. The only way they survive is if they're getting the carbon from that plant. So it's a direct payment because it's right there in that root. The plant has to be willing to pay for those services to the rhizobia. And they do, and they do. And it's so here's even better news. It's not just limited to rhizobia and to legumes. There's all kinds of other organisms out there like azospirillum and zotobacter, and there's a whole bunch of other ones. They're finding new ones all the time that can do the same thing rhizobium do. They break that nitrogen bond. They can make that nitrogen available to a plant in exchange for carbon. And so you think, well, that's great news. Why don't we just go dump a whole bucket load of azospirillum out there and we can grow 200 bushel of corn? Well, the difference is, let me go back to this slide. If you're growing in our area, we can grow 70 bushel soybeans. In order to do that, we would have to put on 350 to 400 units of nitrogen to grow 70 bushel soybeans. It's high protein. It takes a lot of nitrogen. Nobody's going to do that. If you had to put 400 units of nitrogen to grow soybeans, nobody would do it. But these rhizobia can produce 400 units of nitrogen in about 60 days. That's incredible. These guys don't form those colonies. That was trillions of rhizobia bacteria that you saw there. These guys are going to be forming, they're single-celled organisms, and so they are producing 40 to 50 pounds of nitrogen per acre per year. So not nearly as productive, probably not enough to grow a big crop, but it is enough to grow a forage crop. It's enough to really help a cover crop. It's enough to supplement other pieces of the system. And so we don't want to ignore these things because it becomes a very integral part of a system. And especially if you're in a grazing system where you're not exporting nearly as much with truckloads of seed or lots of bales of hay, it can be enough to really drive your system and get a lot of benefit out of that without even having legumes in your field. But here's the thing, all of these things, whether it's azospirillum or rhizobia, they are only going to do this if the plant is willing to give them the carbon in exchange for the nitrogen. And again, plants are smart. Plants aren't going to do this if you keep feeding it nitrogen. So if you have a bunch of excess nitrogen in your soil, the plants are just going to say, thank you very much. I'm going to take the free stuff and I'm not going to go to work. That's what happens in a human economy. It's what happens here too. So if you're continually giving excess nitrogen to your plants, they're never going to trigger these biological pathways to generate these things for themselves because it requires more energy. It requires more resources on their part. And so it's a very delicate balance of how do we wean ourselves off of the inputs to allow these biological processes to kick in and we don't crash the system. So we can talk about that later about how you do that, but you do have to be careful because you can't just pull the plug and go completely over to the system without being very, very careful and cautious how you do it. Okay, the other mineral resources are very important too. So we talked about carbon, we talked about nitrogen. Now there's all these other things that your plants need, phosphorus and potassium and magnesium and zinc and copper. And I told you earlier that your soils have a lot of these things in them. And if you're not sure, send in a soil test and don't just get a regular soil test, but send it into a lab and ask for what's called a TND, a total nutrient digest test. It doesn't cost that much. But a normal soil test is only going to show you what is in your soil that's available to the plant. And it's a very small fraction of what's actually there. But if you ask for a TND test, they will give you a complete analysis of everything that's in the soil, whether it's available or not. And you may be shocked about what is actually in your soil. So that's a very interesting test. But we can unlock that. We can get that by getting these tiny little miners. We have to extract those nutrients from the soil. We have to take them out of that inorganic state, that unavailable state, and put them into a state that plants can use. And so the way that you do that is through biology. And so I love this article that was in Scientific America a number of years ago. It says mycorrhiza fungi run the largest mining operation in the world. The reason this is such a cool article is because when you think of a mining operation, you think of this giant equipment, these trucks that have a tire, the size of a house. You've all seen those pictures. That's mining equipment. But they're saying the largest mining operation in the world is happening at such a microscopic scale that if you don't have a microscope, you're not even going to see it. And that's what they're showing here. So mycorrhiza fungi, very, very microscopic. So the picture on the right is a little piece of feldspar. This is again from the same article. And think of it as a tiny grain of sand. And you see those little brown channels that are cut into that. Those are actually mine shafts. Those are hollowed out areas within that little piece of feldspar where mycorrhiza, they can produce the right enzymes, the right chemicals that literally can dissolve solid rock, solid minerals, turns it into liquid minerals, and they bring that back through their hyphal network and they can trade it, they can sell it to their host plant. Here's what it looks like. Again, highly magnified here. So the little black dots, so this is a plant root, and we're looking kind of inside of it. Those little black dots are actually inside the plant root. So the exchange of minerals for carbon, it's very, very efficient because it's happening inside the plant root. So the arbuscle grows inside the plant root, and then those little strands, those little hyphae, that's what goes out and explores the soil. That's what's doing that mining. That's what's bringing those nutrients in. The author of this article, Jennifer Fraser, she says mycorrhiza, they mine the soils for these basic nutrients, but even for the hard to get things like zinc and copper and manganese. And she says, oddly enough, many soils are rich in important nutrients, but they're often locked up in a physical form, which makes them unavailable to most plants. And she's exactly right. So when you see your soil test and it says, hey, you need to put 50 units of phosphorus out there, that doesn't mean your soil doesn't have phosphorus. It just means your soil doesn't have phosphorus that your plants can get. But it doesn't mean that the biology couldn't go out there and get it. And maybe it doesn't meet all of your needs, but it can certainly meet some of your needs. Okay, the next economic principle is infrastructure. Infrastructure is incredibly important. It's the basic equipment and structures that you need for a country to organize and function properly. And the two most important infrastructures by far are transportation and communication. And we know this because when you go to war with another country, the first thing that you try to do is this. You purposely try to destroy their transportation and their communication infrastructure because you know that will cripple an economy. It will grind a country to a halt if you can do that. And we become so dependent upon these infrastructures that when something goes down, Lauren was talking about earlier, she couldn't make any phone calls on her phone because something was going on with Verizon. Well, just think about if that happened across our phones and across the internet and it persisted for days and it persisted for weeks. What would happen to our economy if you couldn't communicate that way? Well, it would literally grind to a halt. And so these are incredibly important infrastructures. And as I was putting this talk together a few years ago, I got to thinking about, the U.S., strongest economy the world has ever seen. And I think a big part of that actually is because of our transportation infrastructure. So this is the interstate highway system. This was dreamed up kind of during the Great Depression and really put into place in the 50s and completed in the 60s. But this interstate highway system they're big wide roads that allow goods and services to be transported very quickly, very efficiently. Now, if you get a traffic jam or you're in an area that's outgrown your interstates, it's another issue. But by and large, our country has grown because of this transportation infrastructure. But these are big roads and they're only good if you can get to them. So we live down on the Kansas-Nebraska border. I've got to go 50 miles to get to Interstate 80, and I got to drop down about 80 miles to get down to Interstate 70 down in Kansas. And so the interstate does me no good if I can't get there. So what really makes this work is our highway system overlaid with the interstate system. Now there are very few population centers. There's very few people that don't have access to a paved road to get to an interstate highway to get their goods and services where they need to go. So as I was thinking about that, I was thinking it's the same way in our soil. In our soil, we have both of these. So the plant on the left that you're seeing the plant roots, think of that as the interstate highway systems. It's these big, wide, multi-lane roads that are moving goods and services, nutrients, bringing carbon down, bringing water and moisture up. It's the interstate highway system of our soil. It can move large quantities back and forth. But if those roots can't access it, it does no good. And so when you look at that plant on the left, it's accessing very little of the minerals, of the resources, of the nutrients in the soil, and it can put very little of that liquid carbon out into the soil because it's only touching a small amount of the soil. The plant on the right, same plant, but now it's colonized mycorrhiza fungi, those arbuscles growing inside the plant root, that hyphal network going out. Now this becomes the gravel roads, the paved highways. It's bringing stuff to the interstates. It's taking stuff from the interstates back out. And when you have plants that are colonized by mycorrhiza fungi like this, it extends the root system and it allows that plant to be incredibly efficient at pulling in water and nutrients and at pushing all of that liquid carbon that that plant can produce through photosynthesis out into the soil to feed a host of biology, not just a little bit of biology because of just those few roots. And so mycorrhiza, here's another picture of mycorrhiza under the microscope. Super cool how that looks and how that works. It transports phosphorus, which is one of the most difficult things for plants to get out of the soil. In fact, that's probably one of the most important roles of mycorrhiza is being able to get phosphorus out of the soil and into the plant. But also these other things, nitrogen, potassium, calcium, zinc, boron, manganese, and in dry times, they can even help transport water. But again, as much of a superpower as this is, they won't do this for free. They have to have that carbon that's coming from the plant in order to feed them to do it. Now, it's not just them, there's other transportation infrastructure. Earthworms are incredibly important because the burrows, the wormholes that they're putting into the soil allows water to get into your soil, it allows oxygen to get in. They're hauling surface carbon, they're pulling that residue down and taking it throughout your soil system. As they eat residue, there's biology in there. The worms get that in their gut and then they travel to a different part of the soil system, they poop that out, and now that biology has moved. So it's the public transit system, it's the drainage system, it's the big infrastructure of your soil. If you have a soil and you don't have earthworms, you probably have a very unhealthy soil system. And so as you build that healthy soil system, you will start to see the worms start to come back, and that's a really good sign. I wouldn't waste any money doing biological tests on my soil if you don't see any earthworm activity. Once you start to see some worms out there working, now you can start to spend some money on other types of biological testing. So that's the transportation side. Now, the communication side is equally as important. And think about it, plants have to communicate, they have to be great communicators. Like say they can't move, they have to access all of this stuff from the biology, all of this stuff from the soil. Somehow they have to communicate the needs because if mycorrhiza is just indiscriminately bringing in things going, well, the plant might need that. I don't really know. I'm just going to bring it and see. There are certain things like boron, for example, a plant needs in very small amounts, but if you get too much, it can kill the plant. And it doesn't take very much to be too much with some of these things like boron. And so somehow the biology has to know and understand what the plant is needing, and the plant communicates that by the different types of liquid carbon root exudates it's putting out into the soil. So remember, it all starts as glucose, C6H12O6, but it gets changed into thousands and thousands of different compounds. And it may be amino acids and it's fats and it's all these different things. You see some of them on the screen there. But by the different carbon compounds, the plant communicates to the biology the different things that they need. So carbohydrates and sugars and proteins and fats and lipids and oils, all these different things. And so here's that picture I've been referring to a couple of times. So this is a picture, a really unique picture. Jimmy Emmons from Oklahoma took this and shared it with us. So this is a picture of a cover crop cereal rye growing out in his field. This is in Oklahoma. He had a really good, healthy crop of cereal rye. He's been soil health farming for a number of years, so he had really good, healthy biology. And so at a field day, he dug up some soil. It kind of broke open, and he saw something that intrigued him, this picture. And so he's got a little ProScope magnifying glass he puts on his iPhone. So he's able to digitally zoom in. So this is not under a microscope. This is just magnified through this little thing he attached to his iPhone. And so what we're looking at here is a plant root. So the big white thing going through there is a cereal rye root growing. And all those little things coming off the side are root hairs. That's not mycorrhiza, those are root hairs. But what makes this picture super unique is that this is not growing in the soil. You can kind of see the soil around it, but this was growing in the blank space, the open space of a worm burrow. So when he broke that soil apart, it broke right at a worm channel. And what you're seeing here is, the diameter of a worm burrow. So what, a 16th of an inch, eighth of an inch at the most. And you're seeing that plant root that's growing not in the soil, but in the opening of that worm burrow. So what makes us so unique is not just the root hairs, but look at all the little liquid droplets that are oozing out of those root hairs. And that's the liquid carbon that's being produced through photosynthesis. That plant is saying, I know there's biology out there. I know they'll do great things for me. So I'm going to photosynthesize more and I'm going to pump out this excess carbon into the soil, feed the biology, and let the biology bring me the things that I'm needing. And so that's what you're seeing right there. You're seeing the liquid carbon that is coming out of that cereal rye cover crop being pumped into the soil in order to feed the biology. And so if you do a little bit of math, and this is just kind of fun math, there's 100, let's just say there's 100 drops in that eighth of an inch of a cereal rye right there. Well, John Kemp says, hey, a cereal rye plant can have 2 miles of roots. If you've ever dug up cereal rye, it has a massive root system. And so just start doing the math here, 2 miles of roots. That means 100 million droplets per plant. If you have a million plants per acre, which is kind of a decent seeding rate for cereal rye, it gives you 1 trillion drops of carbon per acre at any given time. So is that significant? Yeah, you better believe it is. But if this soil did not have biology, that plant would not be pumping out that much carbon. And so that's why the good soils get better and the bad soils get worse, because you have to have the biology there in order to trigger additional photosynthesis from your plant, because your plants are not photosynthesizing anywhere near capacity. They can crank it up when they need to, and they'll push the extra carbon out into the soil just like this. So there's other communication going on as well. There's great studies out there showing how plants can communicate with each other. So this is an example of a plant, probably an Australian example since it says watch out, mate, aphids are about. But there's a plant that's being affected by aphids and it's sending signals to neighboring plants. And the way they've done the experiments, they've seen it can be either through the air, through what's called volatile organic compounds, or when these plant roots are tied together with mycorrhiza, so that mycorrhiza can start in one plant, those hyphae can go out and actually go into the roots of another plant. So plants are actually physically connected through that mycorrhizal network, and it can send signals back and forth. And they've got really good documentation of plants that have started ramping up their natural defenses when a neighboring plant gets affected by something. Great article in the Scientist magazine showing this, showing how plants communicate through their root systems, how they communicate through the air. These volatile organic compounds will signal different insects to come in. Hey, I've got aphids here, come in and eat them. But if you have no insects around because you've sprayed insecticides or because you have no habitat for them, all of that signaling will be in vain because there will be no insects to pick up the signal of saying, I've got aphids, I need someone to come help me. That plant will be literally crying out in the wilderness with no one to answer. And so, fascinating article. I would encourage you, if you're interested, you can go look up some of these things. There's lots of cool stuff out there. And so the last category of the economics, the economy, is defense and protection. Because anytime you have a really cool system, it's always going to be under attack. And you need to protect your system from all of these different things. So just here's one example, and then we'll kind of go into a summary here of how the plant does this defense and protection. So this is an example. This is an experiment that students at the University of Delaware did. So the picture on the left is a rock cress plant. It's just a common house plant. They infected that pot with a pathogen called Pseudomonas syringae. And what you see is it makes the plant sick. The leaves start to turn yellow. They'll eventually turn brown, then black. They'll fall off, and then the plant dies. The pot in the middle, same type of a plant. They infected it with the same pathogen. So that plant has Pseudomonas syringae in there, but it looks completely healthy. And the difference is they also treated that soil with a beneficial bacteria called Bacillus subtilis. And so that plant is growing not in the absence of a pathogen, but in the presence of a pathogen, but with a protective good biology, if you will. And so the picture on the right is a highly magnified picture of the root. It looks green because they stained it, they dyed it so you can see the bacteria. But everything that's green there is Bacillus subtilis bacteria. So here's what happened. So this plant started growing. It recognized that it was under attack by this pathogen, the Pseudomonas syringae. It triggered a response. That plant says, I need help. I can't move. I need protection. So it starts pumping out a whole bunch of liquid carbon into the root system. And whatever compound signals Bacillus subtilis to ramp up their populations, it kicked that out. And they've actually grew such a huge population that it became a physical barrier around that plant root that the Pseudomonas could not get through this barrier to infect the plant roots. And so what you see, and this is what we see in all healthy ecosystems, they're not healthy because there's no pathogen there. They're healthy because there's a good balance of good biology and not just the bad biology. And so that's what we want to try to accomplish. We don't need to sterilize our soils. We need to just have that healthy balance. And so, defense and protection, it's important because, we have all of these things that want to affect our economy, water and wind and heat and cold and compaction and weeds and insects and diseases. And really, the best way to defend and protect these systems is you really have to just go back to the principles of soil health. So we want to maximize the roots that we have in the soil. And again, cover crops are going to affect all of these. But it's also the crop rotation that we have. Maybe it's some perennials in there. Maybe it's relay crops, companion crops. Lots of different ways you can do that. We want to minimize the disturbances. We want to maximize the amount of diversity. And the best way to get diversity into your soil is when you're doing a cover crop is to not waste an opportunity and just plant sorghum sudan because it's cheap and easy, but to do sorghum sudan with cowpeas and with buckwheat and with sunflowers and with clover. And I mean, we can, that's what we're best at is putting diverse mixes together because we've seen how powerful that is. And so that's the best way to maximize biodiversity and also to include livestock into your system as well. And then keep that soil covered so that it doesn't wash away or blow away. And so, just kind of as we wrap up and as we summarize here, those are those keys to that healthy soil. And just real quickly, in summary, these 8 takeaway points that I would hope that you kind of get and remember out of this. Number one, economies are so interconnected, so intricately interconnected and interdependent that when you affect one part of the economy, you affect everything. And so, when you start messing with the biology, we farm in such a way that messes up the biology, it messes up the rest of the system and your plants start to look sick. And so, number two, you have to give it welfare. If you've destroyed the biology, you have to become that. I heard a speaker once say that in nature, when you kill something, you inherit its job. And so think about that in your farming system. When you go out there and you kill something, you just inherited the job that it had. And you're killing something bad, but you kill a lot of good things when that happens. And so then you have to step in and do these things. So reduce the amount of welfare. You may not ever get completely away from inputs. That's okay. That's not necessarily the goal. The goal should be to reduce the amount of welfare, get the biology working again, and reduce those inputs as much as possible. Get everybody working again, and then increase your cash flow of currency. Put more living roots in the soil because that's how you get carbon into the soil. Carbon is the cash, it's the cash flow. And so if you're just growing corn and soybeans, you're only about 50% efficient at capturing solar energy. So you need to get a cover crop into the system, get livestock into the system, figure out how to get more plants growing a bigger part of the year if you want to put carbon into your soil. There's no other way to do it. Number four, once you have that carbon in the soil, make these capital investments. Build up excesses of carbon in your soil so that it can turn into soil organic matter. And when you start building that organic matter in your soil, don't come out and do things like this, unnecessary tillage, unnecessary residue removal, because that's like making a long-term investment and then turning it around and selling it next month. Organic matter is a long-term investment. You don't want to sell that off. You need that for the long haul. Number five, take advantage of the free tiny workers. Get as much biological diversity into your system as possible. They're going to manufacture, mine, transport, communicate, and protect. Number six, build and do not destroy your infrastructure. You'll really see your economy grow when you start building these transportation and communication infrastructures with the earthworms, with the mycorrhiza. And as you build that infrastructure, don't come in and do this. Again, unnecessary tillage. I say unnecessary because there are times when it may be necessary, but there's far too much tillage done that's not necessary. Because when you're doing this, you're literally declaring war on your soil because you're attacking your own infrastructure. And you just don't want to do that. You can't build that soil economy if you continually do that. Number seven, protect your economy as soil armor. Can't stress how important it is to keep that soil covered. And then number eight, again, it really comes down to diversity. It's so important for a healthy economy. Whether it's a human economy, the plant economy, you have to have diverse plants, roots, and all of that biology. So farm in such a way that builds the diversity, that it builds your carbon, that it builds that system. And so that's kind of carbonomics. That's comparing what's going on in the soil to the economy of a country. And just kind of in closing, there's my information there if you want to get a hold of me. Probably email is probably the best way to do it. I oftentimes am not at my desk or even here in the state, and so I don't get a chance to return as many phone calls, but I do a lot of emails. We've got really good resources on our
Mhm.
website. You can go to our website and get copies of our resource guides. We've got over 400 videos on our YouTube channel, so I'd encourage you to just take and we're not the only ones that have that. There's lots of great resources out there. I'm sure the Florida Soil Health website is starting to build up libraries like this webinar and others. So take advantage of all of the free stuff that's out there for educational. It's never been easier to learn a lot of these things that are going on. So that is Carbonomics in a nutshell, and appreciate your attention. And we can have a little bit of a conversation now.
Oh, that is so awesome. Thank you so much. I love how everything is just so easy to understand the way you describe it. Really breaks it down for those of us who, unlike Gus, and I know Gus has some questions for you. He is on our board. He's our vice president of the new coalition, and he's also an agronomist. So
All
I'm
right.
sure he's going to have at it with you, Keith. Go for it, Gus.
Yeah, thank you so much, Keith. Really compelling presentation. And I love how you took what might be one of the most complex concepts in agronomy and boiled it down really simple and straightforward, which is always music to my ears. So, for one thing, it's really a pleasure to I've listened to a lot of podcasts you've been on, I think with John Kempf and maybe Rick Clark. Um, and I previously, for the last 4 years, have done work with biomakers who you might be familiar with on the soil
Yep.
biology testing side. So I worked full time with them for about 3 years with folks like Marie Mullins and I think Scott McKelvin, who you've probably worked with more
Yep. I
recently.
know both of them. Yeah.
Um, yeah, and I still use a lot of biomakers testing, a lot of Haney tests, but I ventured out into independent consulting about a year ago. And I have a lot of questions to pick your brain, but maybe start with one that I think really is something that interestingly, in my relatively short career, I've seen a lot of traction pick up on, and that's inoculating cover crop seed. So I was early in my time at Biomakers, and before that, was doing a lot of grower events around the Southeast and really across the country. And I kind of got interesting responses, sort of folks balking at the idea of inoculating cover crop seed or saying, well, we put biologicals on our cash crop, but it seems odd to, invest that in a cover crop. So I know there's, starting to be more traction to it, and I'm seeing more folks who are actually investing in biologicals for their cover crop and seeing benefits. Are there any? I'm just kind of curious to pick your brain on benefits you've seen and why you've looked at inoculants specifically for cover crop as something that boosts, their value.
Yeah, no, that's a great question, and yes, we try to inoculate every mix that goes out the door. Now, if you're just ordering a tote of rye and we don't have the opportunity to run it through the mixer, probably not going to do that. But if it goes through our mixer, unless you specifically tell us not to, it's going to get two types of inoculant on it. The first would be a very diverse rhizobia inoculant. Again, the associations that rhizobia bacteria make with the legumes, you may have to provide that, especially if it's the first time you've ever grown those legumes, because they're different. What will work for soybeans is not the same for cowpeas, not the same for vetch. So there's different families, there's different strains. So we have an inoculant product that has all the different legume rhizobia families in it. But then we also, since we have this custom made for us, we also have things like the azospirillum, the free living nitrogen fixer is in there. We have some bacillus strains in there that help solubilize phosphorus. So just like we want diversity in our seeds, we want diversity if possible in our cash crops. It would be, I don't know why you would want to put on an inoculant that only has one thing in it when you could put on an inoculant that has multiple things in it. And so that's the first thing would be that Rhizobia Plus package. And that generally will run, anywhere. It depends on how many legumes you have in there or how much that we put in, but that's generally going to run anywhere from 75 cents to $1.50 an acre for that. And then we also put a liquid uh, compost extract. It's a highly fungal type compost that we're making an extract out of. We own part of a company called Elevate Ag, and we're actually going to be making those products right here in Kansas and Nebraska. And so and it's really cool because we sent it in to biomakers for that metagenomics test. And I mean the report on what's in there is 40 pages long. You've seen those. So it's incredibly diverse, but it's also very inexpensive. So you're limited on how much liquid you can put on seed without risking it getting too wet. So, 6 ounces per 100 pounds of seed, that's going to cost usually 50 cents an acre or something. So our goal when we do that is to try to keep that inoculant cost under $2 an acre for going out, and sometimes it's even less. So that's kind of that base package, and it gives a really diverse spread of lots of different organisms that are in there. And it's not just the organisms, it's also the signaling molecules that those organisms have made, because that can trigger plant responses through, sped up quorum sensing and things like that. So it's not just the organisms, it's also some of those signaling molecules. We also have inoculants. We have, the mycorrhizal inoculants, and this is where you start getting a lot of added costs because most of these bacteria, well, all these bacteria, you can start with some really good stuff. You throw it in a vat, you can ferment it, you can go through this process. A bacteria may double its population every 12 to 13 minutes. So you can exponentially blow up, a little bit of bacteria into trillions of bacteria literally in 24 hours. So it's relatively cheap to do bacteria. Mycorrhiza fungi is a whole different deal. That has to grow on a plant root. And so the process to grow and manufacture and make mycorrhiza available is significantly more expensive because it's so labor intensive. And so to put mycorrhiza inoculant on something is going to cost you probably anywhere from $8 to $12 an acre, depending on your seeding rate and full rate and all that. So is that still a good investment? Absolutely, I think it is, especially on a cash crop. Do we do that on all our cover crops? No, because people aren't going to have the tolerance to spend another $10 an acre. Now, they might if they're coming in with a really valuable cash crop next. They might if their soil is just so completely degraded, they don't think they have anything there to begin with. It's probably worth that investment. But if you know that you probably got some out there and you're building the system, you can grow those native populations by providing the right environment with that. So that's our stance. If you plant cover crop seed that is not inoculated with a biological, you've missed an opportunity. It's by far the cheapest and easiest way to get the biology in the soil, and it doesn't cost that much. So you're really wasting an opportunity if you don't have your seed treated with some sort of biological product.
Thank you. And I have done some work with Elevate Ag, and I think they've shared some of their results publicly. So I can say they've had some really strong results of their testing their inoculants and
Mhm.
their compost tea. Yeah.
Okay, Gus, did you have anything else?
I did. For the sake of time, I probably shouldn't dive into anything super complex, but I'm also really curious to ask Keith a question. This is I'd say, a step more technical than inoculants, but it's actually on the same topic. So, I've listened to a lot of, or read a lot of the research and listened to some podcasts with folks who are experts on endophytes, meaning bacteria and fungi that actually live within the crop, beneficial microbes, not so much pathogens. particularly Dr. James White out of Rutgers and Dr. Mary Lucero, who are, I think, the foremost experts here in the US on bacteria and fungi endophytes, respectively. And they've suggested, I think, both and proven actually in their research that plants will go, and this I think speaks to why inoculating cover crops shows benefits to the following cash crop as well, is that when you plant a seed, it actually contains some of those beneficial endophytes that microbe, when plants go to reproductive stage, when you go to harvest cover crop seed or you cash crop seed, some of the beneficial microbes from the soil, the plant will actually transport and place in the seed that then will go into the soil. And I've had gotten some interesting conversations from folks who worry that their seed, if it is coming from a source where the soil is really sterilized, heavily tilled, going through a lot of fungicide applications, they're not going to really, that's plant isn't going to be able to pass on those microbes into the seed that these researchers have shown that they can. So Keith, the question for me is this, and I may have even heard you discuss endophytes in some of these podcast appearances and presentations. Is that something that you consider in sourcing and producing your own cover crop seed, whether or not they're, you're setting up that seed to actually sort of be its own internal inoculant when it comes to particularly those endophytic beneficial bacteria and fungi?
Yeah. Yeah, no, great question. And yes, we could be here, till next week talking about this probably. Well, if somebody knew more than me about it, because yeah, it's a huge topic. So yes, that we absolutely do. John Kemp has published some really good information in a number of our resource guides. There's at least a couple of them that we have an article from John. I think it's called Seeds with Speed, and he talks about that. He talks about the biology that a seed brings, kind of onboard biology. Christine Jones was here a couple of years ago, and the numbers that she was talking about is staggering. She said an individual seed can have, I don't even remember what she said, but I think it was like 8 or 9 billion microbes in an individual seed if it's coming from a really healthy environment. And that's incredible to even think about. But yes, and it's not just in the seed because it will be inside that seed in the embryo, but it's also on the seed coat. And you referenced James White, and what some of Dr. White's research has shown is those bacteria, those endophytes that are on that seed are what causes a root to develop root hairs. So I showed you that picture that had all those root hairs, and that's where all that liquid carbon was coming out. Well, they've taken seeds and they've sterilized them. They've hit them with Clorox or whatever to basically sterilize the outside of that seed. And then when they plant that, they will see that root develop almost no root hairs. And so then the whole rhizophagy cycle that I'm sure you're familiar with, none of that happens very much or very effectively without those root hairs, without those root tips. So it it handicaps your whole system. You're starting out from a negative position when you start with a seed that doesn't have much biology. So the best thing to do is to have the biology on board in and on the seed naturally from its growing conditions. So we probably 60 to 65% of the seed that we sell, and we sell about 30 million pounds a year. So 60 to 65% of that is grown. We grow that not on our own farm necessarily, but through our grower network. And so we are in direct control of that production. We know those growers. We visit those growers' fields. They were all customers of ours first. So we have some control over that. And they're not all 100% regenerative, but they're all doing at least some regenerative practices. So we're confident that we're getting some good biology. And I've had conversations with biomakers and Rise Bio and other places of how do we start using metagenomics to look at what's in the seed and not just the genomics of the soil. So we're working on trying to prove some of these things that we think are happening. So that's the first thing is you want seed grown in a regenerative environment as much as possible. Can't always, that doesn't always happen. And it may not be the exact biology you need. You can always supplement that by adding other things to the seed, the treatments that we just talked about. So that's a supplementation to what's already there naturally. And then you can start to rebuild. So if you take a seed that has very little of that bacteria in it to begin with, you can start to build that back up by having it planted into a really healthy ecosystem because it will pull those some of those organisms out of the soil. In a diverse plant mix, plants will actually swap and share bacteria and other biology back and forth with each other. So the same seed grown in a diverse environment will be a much healthier seed than something grown in a monoculture. Now it's really hard to harvest seed in a diverse seed mix, but those are that's the way nature works. So there's things you can do to make a seed that started out with kind of a low biology. You can add biology, plant it in a healthy system. You talked about endophytes. There's some good research out there with Walter Goldstein with the Mandamin Institute has some really cool research that he's doing with root and leaf endophytes in corn. So corn's not a legume, but he is getting corn to make associations with biology, and that biology is providing the nitrogen for that corn. So his goal is to produce corn seed that doesn't need additional synthetic nitrogen fertility because it has the ability to make these associations. And much of that is some of that is leaf endophytes, some of it is root endophytes. And so fascinating world of research. I was in a room, yeah, with James White and with Mary and with Walter Goldstein and Christine Jones. And I mean, what they were talking about was way over my head. But it's super cool to think about. And it's really, really cool to think about what the future could hold, especially with the power that AI is bringing to research. It's going to infinitely speed up all of these processes. And I think the change that we're going to see in the next 5 to 10 years is going to blow away what we've seen in the last several decades. And so that's exciting to me because I think there will be much more advances in biology than there will be in chemistry because there's so much more we don't know. We know most everything about chemistry. We know very little about biology. And so, as we get the technology to help unlock that more, I think we'll see huge advances in that field. And I can't remember. Somebody said the other day that they're projecting in 20 years the amount of money that U.S. agriculture spends on biologicals will dwarf the amount that we spend on chemicals. Wouldn't that be a great day?
Absolutely.
Oh, right.
Yeah.
So, Missy, I wanted to ask you first. I have one question that I think is going to bring it all back down to like our lowest common denominator here in Florida. Why don't I do that first? So, Missy, if you've got some, or Missy, you jump in. Do you have one for him?
I feel a little overwhelmed right now with all this information. I'm not as well educated and up to speed on all the biology and the soil. I'm still learning. Um, for me, I'm a small time farmer. Micro farmer is what I'm going to start calling myself over here. We're coming into this farm in Jacksonville, Florida. It's super sandy. We've gone to tree farmers, and they say, hey, you get this tree and you plant it in the ground, put a little bit of you know compost in with it, and you're going to be able to grow it. We've tried that, we've failed, we've had lots of failures trying to grow on this property, because there is no biology in the sand. So we're still trying to figure out how to do that. We've taken some measures. The whole cover crop. We started out a couple years ago, trying to do a big diversity of cover crop and just broadcasting it out on top of an area that we had chickens run across and sheep run across, and we thought that that was going to provide enough nutrients into the sand that would allow those cover crops to grow, and it didn't. So we're still learning how to put those into place. Yeah, I'm overwhelmed with all this information. I don't know what our best route would be.
What crops are you growing?
Um, so we have a food forest. So we're growing a lot of different fruit trees. And then we have a lot of different vegetables that we grow. We would like to be able to grow forage for our sheep. We haven't been successful in doing that at all.
Yeah. And pretty sandy soils, I'm assuming.
Absolutely.
Yeah. Well, when you're starting again at such a you're starting at such a low level, it's going to be very difficult for all these biological processes that I talked about to kick in. Because plants need the biology needs the plants. You don't really have either one going, and so it's going to be a real struggle. So, and especially since you're on a small scale, that gives you the ability to do things that you could never do at a large scale. So really, probably what you need to do is to be importing carbon. Some of that's going to be through compost. You just have to figure out how to get carbon into that system. You got to be careful that you don't overload the system with, get things way out of whack. So, like if you spread a foot deep layer of wood chips, you'll have your nitrogen tied up for so long that nothing's going to grow in there. So something that's more composted, something that's more finished, more balanced is going to be much better. And so, I know you added compost when you planted that tree, and so, I don't know exactly, what was going on there, but you've got to get some carbon in that system to get it started. So carbon, and then get plants growing and get the biology in there, and then yeah, it's probably going to start slow. It's going to start, um, you're starting at such a low level. If you go onto our website, if you go to greencover.com and just go to the little search button, type in saving citrus. We have a really good article. It was in our resource guide, I don't know, 4 or 5 years ago. Ed James, I don't know if any of you know Ed James. He's a citrus grower in Howie in the Hills, just outside of Orlando. I was actually visited this place in April when I was in the area for a wedding, but obviously citrus greening, taking out most of Florida's citrus. He was about to give up on this orchard. It's a really cool story because there was this great big alligator that was, terrorizing his kids, and so he had to go out and take care of this alligator. Well, he just went out and buried it in his citrus grove, and then the next year, all that fertility, it made all of the native vegetation just explode, and he had all this diversity growing around where he buried this alligator carcass, and those trees right around there stopped showing any signs of citrus greening and actually reversed all that and were all of a sudden incredibly healthy. And so then he started planting cover crops and adding biology, and he's essentially got healthy orange groves in the midst of citrus greening all around him. And so it's a really cool story and a cool testimony to how he turned that around, with these biological processes. But what jump-started it was a huge infusion of nutrients and carbon in the uh, case of that alligator carcass. So, I guess the answer could be go kill an alligator and bury it next to your tree, I guess. But
Well, would a chicken work?
probably.
You know,
I mean, it's no
we,
different. The Native Americans, they bury the fish right next to their mound of corn, beans, and squash because that was the jump starter. Because it's a perfect balance of carbon and nitrogen in a carcass has that perfect balance of those nutrients, so the carbon and nitrogen ratio, and it's also when it becomes a carcass like that, it's also the nitrogen is in amino acid and protein forms, which is much easier for a plant to uptake than trying to process. The process of getting atmospheric nitrogen into a plant is incredibly energy efficient or incredibly energy intensive, but they can uptake amino acids and proteins very easily. And so, yeah, if you got any types of those sorts of animal products that you can put out there, I think you would really see that jump start. So read that article called Saving Citrus because that's happening, right in Florida and some really cool stuff that's going on there. He's very frustrated because he can't get the University of Florida to listen to him or change any recommendations. They just want to stick an IV tube in a tree and, treat it with antibiotics, which I saw that there and I couldn't believe it. If I hadn't seen it with my own eyes, it's like this makes no sense whatsoever.
No, I heard a podcast recently about the saving the citrus. I'm not sure if it's the same one you're referring to. And they went into discussing hairy indigo.
Yeah.
Is that what you're the same?
Well, I mean, it would be a legume cover crop that's very well adapted to down there. So yeah,
Okay.
yeah. Plant anything that will grow, anything you can get to grow, and look at your native vegetation. Don't be afraid to just let your native vegetation grow. If you can't get anything else to grow, let the
And
native stuff grow and start there.
absolutely. No, we've done that. I mean, we have areas, we're on 3.5 acres, so we're a micro farm is what I'm going to call it now. So we have areas that we have, heavily invested our time and energy into trying to build soil, and then we have other areas where we haven't. The areas where we haven't, it would just it would be so nice if there was some magical, thing we could just throw down on the ground and say, this is going to work. We know that we have to put more effort into it. We're just trying to find a balance that works for us.
Yeah. Yep. Just yeah, find what works and start small and just kind of let it build from there.
Yeah, I think I'm going to follow up on Missy's question, and I think you really already answered part of it, and that is the chicken and egg problem that the farmers here with all the sandy soil. But I also want to say, on behalf of the Soil Health Coalition, thank you for being here. Our own personal experience, we have spent thousands of dollars on cover crop seed that absolutely just did nothing over the years here. But the green cover seed is growing. I mean, I wouldn't believe it if I didn't see it. But literally, I'm cheap, so I love to buy your deer plot mix because it's a bunch of stuff, and my cows will eat it. But you talk about this. What is it called? The Green Boost 2.0, and I'm wondering, Keith, how much of the fact that we have plants growing in our sand has to do with that biology. I mean, I think that's just really the point of your whole talk, but
Yeah.
really, truly. And then the follow up to that is, and you and I have talked about it a little bit, is we have added a little bit of, we're bringing in, I think part of the problem with the regenerative movement is that we are taught, oh, you don't need anything. Just run your cattle, spread your chickens out there. Don't bring in anything from off your farm. Well, we have added some cow manure and some chicken manure and then a processed, but it's an organic fertilizer, and I think that is helping. So I think maybe if you could, if it's possible, give permission to some of us to not be so pure. Combine what you
Yeah.
have with something that's going to give a boost. So if you could just
Sure.
speak about that a little bit.
Well, so the Green Boost it's basically just kind of a little package name for those two inoculants that I described. When we put those together, we just call it Green Boost. So that's what you're getting. That's what you're seeing is those two inoculants that I described earlier. As far as, yeah, I certainly have heard and come across people that are purists, you don't need to bring anything in from the outside. And that is probably true at some point when you reach this plateau of everything is working and cooking but that's only going to work if you're also not exporting anything out. And if you're going to be a grain farmer, you're going to export quite a bit. Hay farmer. Now, if you're raising protein, livestock, 80% of what goes in a cow is coming back out the other end. So it's a much more efficient system and requires far fewer inputs because you're cycling those nutrients so much better than when I haul grain or a hay bale away. That 100% of that's gone. Versus a cow, only 20% of that is going to leave my field. So that's a much better system if you can do that and incorporate that livestock. So the concept of not having to add anything is it's possible, but it's a long-term goal. And then you would have to be in a system where you are not exporting very much at all. And so I don't think that should be our goal. Our goal should be number one, to be profitable, because if we're not profitable, we're not going to even be around to continue to build the soil. So we have to be profitable, number one. We can't always grow more bushels or more pounds or get more dollars for our product. So then the only way to become more profitable is to spend less money doing it. And that's probably the easiest way to increase profitability. And that's where the reduction, welfare is expensive. And so when you're spending all that money to supplement the plants because your biology is not working, it is difficult to make any money growing anything. When you start to reduce how much you have to put out there and you're letting the biology do the jobs that it's designed to do, now you're a much lower cost producer and there is some margin to be made. So you got to be profitable. That's got to be your number one goal. And then number two, yeah, you should be trying to build that soil for the long run, for the long term. One of the easiest ways to measure that is just be measuring your organic matter, soil organic matter. That's a cheap test. It's pretty easy to do. There's other things that you can do, but be looking at, what is your water infiltration rate? That's a free test to do. You can test that yourself. Do you have earthworms out there? What does your soil smell like? There's lots of things that you can do every time you're out in your field to be getting indications of whether or not you're moving in the right direction. So you got to be profitable and then you work on these other things. But I can't stress that enough is that if, you know, unless you're independently wealthy, then you can do all of these fancy things and not worry about getting any profit out of it. But we have to keep money in the system to keep it going.
Absolutely. Another thing I know your buddy Gabe Brown talks about is maybe even just take a smaller piece of your land and experiment with it and
Oh,
try
for
different
sure.
things, right? And which is something we've been doing. I think we were a little overwhelmed at trying to cover, 60 acres of pasture and make it all better overnight. And now we're breaking it down. We're starting with our best pasture, and that's where things are going well. And then we're going to export from there. All right. So before we let you go, I do have a question. I'm going to put you on the spot, Keith. So we have the Florida Soil Health Coalition. We're trying to build up our membership. Is there any little coupon or little giveaway that you might offer people who join our coalition? If they buy seed, they would have to buy seed from you. But if they buy seed, would you kick in a little something for us?
Well, we have done some different things for other entities and organizations. So, yeah, let me send you an email on a program that we could potentially set up for that because we've done that for other entities. Yes.
That would be awesome. And listen, it doesn't even have to be huge, but just something to incentivize and get people to look at your website. And we so appreciate, by the way, the website is fantastic, not just about selling cover crop seeds, but educating people about all the diversity, on the different things that you can plant in your locality. So thank you. I mean, for just offering so much free information for people who are trying to go down this road. It's great. We appreciate it. And I think that's it. Unless anybody, Toby, do you want to say?
No, I'm going to say I'd say we don't have a lot of earthworms. I'm always very excited when I see them.
Other than the ones
And
we
well,
grow
you
in
know,
our old
we have our own
PBM
that we're
tip.
doing, but but it did make me think I haven't gone out with a shovel lately and checked some areas. So I'm going to possibly try and do that tomorrow.
And before we go, Catherine, did you want to ask Keith anything? She's off camera the whole time.
Oh,
There she
Yep.
is.
sorry, I was preoccupied. Oh no, there's an echo. Oh no.
Yeah, you
Oh.
got to kill one of those.
Okay, well, can you hear me?
Yes.
Yes.
I would say, okay, so my question is more broad than all the specifics you were talking about, but if you could tell the general public one thing about soil health, what would you spread the word about?
Um, I think that what I would want them to know is that soil was created as a very healthy ecosystem. We have broken it, but it wants to return to that. And so as we intentionally work towards getting it back that way, the system will work with you. And you will be amazed at, once you get all these pieces in place, now if you're so degraded, it's going to take a little while, but the system wants to return to the way it was. And so it's so much easier to do that when you're working with the natural system versus fighting it. And maybe you can't do that across the whole farm, but like Lauren said, maybe it's just a garden box or a corner of your garden, but see what you can do. A really cool book that I read, David Montgomery and his wife Ann Bickle. David Montgomery wrote Dirt, the Erosion of Civilizations. But then he's written a whole other number of books, and he's a geologist. But what they discovered, all of these things, and now he's one of the most influential guys in soil health. And they all did it because they had a garden in their backyard in Seattle, Washington. And they were bringing coffee grounds from all the local Starbucks, and they were using coffee grounds as their source of carbon. And they saw how quickly they could change their crappy Seattle clay soil to something really, really good and healthy. Now, they infused huge amounts of carbon into it, but they saw a sped up way to do that because they were willing to work on it on a very small scale. So I think that's what I would tell people is the system wants to get back to a healthy ecosystem. You just have to figure out how to be a partner in doing that.
That's beautifully said.
Yeah.
Oh, yeah, that was great. Thank you. I hate to tell you this, but that's going to be your soundbite on my Facebook page.
Well,
Thank you,
I've been
Catherine.
quoted worse.
Yeah, no, it's awesome. This was really fantastic, and I'm so excited that we'll be able to put it on our website and have everybody who probably didn't get the right password. Oh my gosh. Anyway, everybody will be able to watch it at their leisure sometime in the future. And thanks again so much, Keith. And again, as small growers, thank you for producing such a great seed and then inoculating it with all this great stuff.
You're welcome. Thanks, everybody.
All right. Have a good night.
Good
Take
night.
care.
Have a
Bye
good
bye.
night. Take care.
All right, guys. We'll see you guys soon. Take care.